AMC 10A 2018 problem 4. So we have a student who wants to schedule 3 math courses in a 6-period day, and no 2 mathematics courses can be taken in consecutive periods. And we're trying to find the number of possibilities that this can be. So I've outlined the 4 cases that it can be at, where A where A, G, and N denote the 3 math courses. So we don't really care about all we care about is that these 3 are math courses. So for the sake of simplicity, I'm just going to call them M for simplicity. So therefore, AGN all fill a math slot. In this slot, we showed in case 1 that they're all equally spaced from one another. And this can result in such a pattern. And likewise, we can alternate the X in the math courses to get XM, XM, XM. But then we must also consider if they're not always consecutively close to each other. What if one class is 2 periods away from the other 2 classes? And this is outlined by case 3 and case 4. And this shows us that the last 2 classes are 2 blocks away from each other, or the first 2 are 2 courses away from each other. And now, if you're wondering how I developed the ability to map out all the case scenarios, this takes practice and it takes a lot of ingenuity and experience to understand how to creatively understand the question. But even if you do not have a lot of experience doing probability, this should come as no surprise to you because we know that there are 6 spaces, and if no 2 can be consecutive, we always have 1 space difference. But we also have these spaces and these spaces to consider because these spaces also deal with terms that can be an example where each case is not always consecutively 1 period apart. So, by messing around with your understanding of the question, you can always deduce down to these scenarios. And now that we have these scenarios out the way, how many possibilities are within each case? Now, these are caseworks because these are all independent scenarios of each other. Well, within this period, G can fill out the slot of A, G can fill out the slot of N, or G can fill out slot 2. But if G fills out one of the 3 slots, then the rest of the 2 slots can be only open to 2 possibilities for 1 course. So this means that for each case, we only have 3 factorial possibilities within each case. So within case 1, we have 3 factorial possible arrangements of AGN, and likewise for the rest, because we always have 3 math courses that we're trying to alternate with each other's positions. Now, this 3 factorial comes from the very basic counting principle. So, since we're dealing with casework, we sum every case. And since we have 4 summings of 3 factorial, we just multiply 4 with 3 factorial. This is the same thing as 4 times 6, which gives us 24, bringing us to answer choice E with 24.